Okay, so let's continue our discussion in Gauss-Seidel method. So solve the system of equations using the method and correct up to 3 decimal places. Okay, so we try to write the augmented matrix for this one. This is equal to 1, 2, 1, and then 3, 1, -1, and then 1, -1, 4. So our matrix doesn't look like a dominant one. So, gagawin natin, we need to rearrange the given equations to give dominant diagonal elements. Kasi diagonal elements natin is really not dominant. So, what we should do is to interchange si first equation sa ating second equation. So, if we do that, our new augmented matrix will be okay, so interchange lang si first and second row. So this will be equal to 3, 1, -1, 1, 2, 1, and then 1, -1, 4. So we will not be using this augmented matrix, but rather we will use this matrix since this have a dominant diagonal elements. Okay, so our B is equal to 0, 0, 3. Okay, of course, nag-interchange din yung ating first constant and second constant. So, initial guesses natin, let x raised to 0 be equal to 0, y raised to 0 be equal to 0, and z raised to 0 be equal to 0. So, let us now solve for the first iteration, k equal to 1. So, our x raised to 1 is equal to b raised to 1 minus a12, and then y raised to 0 minus a13 z raised to 0. Since k natin is 1, this is 1 minus 0, so 1 minus 1, so that is equal to 0. And then a11. So our x raised to 1 is equal to b raised to 1 natin is equal to 0. Okay, so b raised to 1 is equal to 0 minus a12 natin is equal to 1. And y raised to 0 natin is 0 minus a13 that is equal to -1 multiplied by z raised to 0 that is equal to 0. And a11 natin is equal to 3. So our x raised to 1 is equal to, of course, the numerator is equal to 0. So 0 over 3. And x raised to 1 is equal to 0. Okay? So now let us continue to solve for y raised to 1. Kasi x, y, z pala yung ating variables. So, at y raised to 1, this is equal to b sub 2 minus a21 and then x raised to 1 minus a23 z raised to 0 all over a22. So, our y sub 1 is equal to, what is b sub 2? That is equal to 0 minus a21 natin, that is equal to 1. And then, x sub 1 natin is equal to 0 minus a23 natin, that is equal to 1 times z sub 0 natin, that is equal to 0. Okay, so for this 1, so that will be equal to a22 natin is equal to 2. So, of course, our numerator is equal to 0. So, our y raised to 1 is equal to 0 over 2. And y raised to 1 is equal to 0. So, let's proceed to z raised to 1. So, z raised to 1 natin is b sub 3 minus a31 x sub 1 minus a32 y sub 1 all over A33. Okay? So, plug in na natin yung values. This will be equal to 3 minus our A31 is equal to 1 multiplied by x raised to 1 that is 0. A32 natin is negative 1 multiplied by y raised to 1 that is equal to 0. All over A33, what is our A33? That is 4. So this is 0, this is 0. Z sub 1 is equal to 3 over 4. So our Z sub 1 is equal to 0.75. Okay? So now let's proceed to second iteration. Second iteration, k is equal to 2. So solving for x raised to 2, okay, solving for x raised to 2, this is equal to b raised to 1 minus a1 2 y raised to k minus 1, so that is 1, minus a1 3 z raised to still equal to 1, and then over a1 1. So x raised to 2 is equal to 0 minus a1 2 natin is equal to 1 multiplied by y raised to 1, that is 0. A13 natin is negative 1 multiplied by our z sub 1, which is 0.75 all over 3. So of course this will be equal to 0. This will cancel. And we have x sub 2 equal to negative times negative, so that is positive 0.75 all over 3. So x sub 2 or x raised to 2 is equal to 0.25. Okay, so let us solve for y sub y squared. So this is equal to b sub 2 minus a21 y a21 raised to x raised to 2, I should say. So x squared, so k natin is equal to 2, so x raised to 2 minus a23 z raised to 1 all over CA22. So y squared natin is equal to 0 minus A21 natin is equal to 1. And then x squared natin is 0.25 minus A23 that is equal to 1 multiplied by z sub 1 that is z raised to 1 that is 0.75. And A22 natin is equal to 2. So solving for y raised to 2, that will be equal to negative 0.5. So now let us solve for z raised to 3. So this is equal to b sub 3 minus a31 raised to x raised to 1 or x raised to 2, I should say. So x raised to k siya. And then minus a32 y raised to 2 all over si a3 3. So this is equal to b sub 3 natin is equal to 3 minus A31 natin is 1 multiplied by 0.25 minus A32 that is equal to negative 0.1 multiplied by our y squared that is negative 0.5 all over A33 natin is 4. So solving for z raised to 2, this is z raised to 2 pala. Since k natin is equal to 2, I'm sorry. So, z raised to 2 natin is 0.5625. Okay? So, that is how you solve for a Gauss-Seidel method. Okay? So, that is how you solve. And then, important note lang, if the absolute value of the largest coefficient in each equation is greater than the sum of the absolute values of all the remaining coefficients, then the Gauss-Seidel iteration method will converge. If this condition is not satisfied, then Gauss-Seidel is not applicable. Okay? So, sa previous example natin, it was assumed that coefficient A11, which is this one, coefficient A11, this one, si A11, A22, and A33 are the largest coefficients, which is true. because if you add this one and take the absolute value, so if you add this one and take the absolute value, it will be less than the first element. So, nasatisfy natin or nag-converge yung ating Gauss-Seidel iteration. So, we applied si Gauss-Seidel method. And the diagonal elements of the augmented matrix must have the largest coefficient in each equation, just like sa ginawa natin sa example number 2, so that we can consider the augmented matrix having a dominant diagonal elements. So those are just important notes in using the Gauss-Seidel method.